In this next video, we're going to talk about a part-to-part ratio model. So before we do that, you'll notice in your packet that there's a paragraph on what a ratio and a rate are. So let's review this before we start the next problem. So in the next two problems, we will use the terms ratio and rate. Both ratios and rates compare two quantities multiplicatively. So we talked about comparing things multiplicatively in the last problem, and we'll continue to look at that idea as we continue on. Meaning, we compare their relative size by expressing them as a fraction. Rates are also considered ratios, but have one notable difference. Rates have the special distinction of comparing two different types of units of measure. For example, your hourly pay rate tells you how many dollars you make per hour. The two different units are dollars, which is money, and times, which is hours. So, all rates are ratios, but not all ratios are rates. So, ratios may compare distance with distance, maybe feet to feet, or seconds to seconds, and rates have two different types of units. So now that we've defined those, let's look at our next problem. So here is our ratio part-to-part model. And typically when we talk about part-to-part models, we frequently refer to them as ratios, even though they're not the only type of ratios. For some reason we use the word ratio when we talk about part-to-part. Okay, so here's our question. Let's highlight important information. How has 4 chocolate candies and 8 peanut butter candies? So that's our given information. What is the ratio of chocolate candies to peanut butter candies? So notice in this problem, the question asks for the ratio of chocolate candies to peanut butter candies. The other ones were asking for the fraction, okay, and it says to represent this as a fraction. So just again, notice in this part-to-part model, we typically use the word ratio, even though it's not the only type of ratio. Okay, so we can think of the ratio of 4, and notice it says chocolate candies to peanut butter candies. So we use this exact order. Chocolate will come first in our ratio, and peanut butter will come second. Okay, so our numerator is the chocolate candies, and our denominator is, I'll put PB for the peanut butter candies. And again, these are the numbers of. So we're always talking about numbers when this is math. So our fraction would be 4 over 8. Okay. So 4 chocolate candies to 8 peanut butter candies. And notice I even use that language. I said 4 to 8. Another way we represent this sometimes, in case you see it, is with these part-to-part ratios, we frequently use colons, and this is, we say this, just like we say this, 4 to 8. Okay, and the idea is when you're comparing parts to parts, you can actually see and think of this a little bit more multiplicatively, more easily. Okay, so when I see this 4 to 8, I'm not thinking of the difference of 4 and 8, which is 4. Okay, but I can easily see that there are twice as many peanut butter candies as chocolate. Okay, and notice this isn't something we were asked to do, but these are ideas that you want to start thinking of when you're thinking multiplicatively. Okay, so again, this is multiplicative because if I multiply 4 times 2, I get 8. That's how I know there's twice as many of the peanut butter as there are chocolate. And in this ratio context, we don't usually say the difference is 4, even though it is. That's not what we're really interested in. Just like in the last problem, we weren't as interested in the number of questions that were incorrect as the number compared multiplicatively to some other number. Okay. Let's look at the next question, another part-to-part ratio. Tia won 6 games of heads or tails and lost 6 games of heads or tails. So that's our given information. What is the ratio of games won to games lost? Okay. So notice they ask for a ratio, and again, that's very typical with part to part. Doesn't mean it's absolutely a part to part, but very typical. And notice it says games won, so that's the first part. That's a part of all the games she played. 2 games lost. This is the second part. Okay. So just as a comparison, when we had a part to whole model, it might say, what is the fraction of total games that she won? Then we want to look at the games she won to the total number of games. Here we're comparing the games she won to the games she lost. So as a fraction, this is number of games won over number of games lost. Okay, and it says she won 6 games of heads or tails, and she lost 3 games of heads or tails. Okay, and this is our fraction. Okay. And again, we can also write these as 6 to 3, because we do this with part-to-part ratios a lot, or 6:3. And notice, things I'm thinking, you can say, well, she won 3 more games than she lost. And that's interesting. But we can also say she won twice as many games as she lost. Okay? And notice how the ordering matters. Okay, so here, the second number, the peanut butter, was 2 times the chocolate. Here the first number is 2 times the second number. Okay? So if we had asked the ratio of games lost to games won, we could reverse this order, but you still need to know what each of the numbers are referring to. Lots of times when we write it as a fraction, we don't include the units like we did here. So it's important when you're given this information, you could look back at the question and see what it's referring to. So 6 is referring to number 1, number of games won, not the number 1, and 3 is referring to the number of games lost. We're going to look at the rate model next.